Well, hi, good morning. Thank you for joining me here in my shop. Today is May 13th, May 13th, right? Almost the middle of May. And it's another gray, rainy day outside, unfortunately. So, okay. Well, all fingers are pointing at this capacitor as being the cause of the problem here. So, I think that's what we have to obviously focus on next. There's 3 sections in the capacitor. It would only take one shorted section, the worst one or the best one or the right one, to cause all the effects that have been happening. The blown diode, the overheating resistor, the hot power supply, transformer, all of it points to this. So frankly, I don't know if I've ever encountered a real short circuit in one of these capacitors before. So that's why I'm so hesitant, even though it seems to be obviously the problem. Next step along the way, I think, will be to remove some wires. I think this particular section is the one that's going to be the troublesome one. And then do some tests, see what we can find out about it. But ultimately, I'm on my way to replacing it. And it's a 50-54, and the voltage on this won't matter much because 50 plus 50 plus 4, and say the voltage. There it is, 350. Looks like 350 slash, could say 350 slash 450. Well, that's easy to replace because I've ordered, recently ordered the kind of capacitors I need to do it. So fantastic. Okay, we'll get busy on that. Okay, let's. I've taken the wires off this one terminal, so the diode and this wire back here are now free. So that's just totally empty. Nothing hooked up there. Let's just. Now this is not exactly the best way to test the capacitor, but just with an ohm meter. Well, I have the feeling it's going to test, like based on this test, I don't think we're going to find anything. That's funny. I guess I charged it up, and then maybe as I change the scale on my meter, the charge on the capacitor is more than enough to make it show that. A little odd behavior. 60,000 again. Okay, well, I guess that's what's happened. Let me short it here. Scale. Charging up. And then we can't get a reading because it's charged up. Oh, there we go. Got something there. It's going down. Well, that must be because the voltage output of the ohm meter is different on different scales. I'm gonna guess that's what's really happening here. Well, that doesn't look like a short at all. What about the rest of these wires? What about this wire here? Let me just make a connection to the chassis here, and then we'll check this wire. Are you shorted, Mr. Wire? I wouldn't say so. I'll bet you there's nothing wrong with this capacitor. That's what, if I had to put money down, that's what I'd be wagering. Why did I think I saw a short circuit on it? Because it's the only device in town. What am I doing here? I don't even know. Only device in town that can generate the short circuit I'm looking for. Again, this is not the best way. Look at this diode still in the circuit here. I doubt anything happened to this. It's a 1 amp diode. And yeah, I don't think there's anything wrong there. Well, there's one more terminal to test. Now this last terminal, I think, I don't really know actually, is the small one there. There we go. I'm up on the 6 meg scale, so that's 300,000. 400, 500,000. Well, that's not enough of a short to cause anything to happen. I'm not finding a thing about this last terminal. $500,000. And what happens if we put it on this scale? The charge dissipated quickly, but the capacitor is still wired in the radio. This is going right up. Over 600,000. I don't think there's anything wrong with this capacitor. I think the problem has to be either further in the radio, or what else could it be? Look at the schematic. I think I'm just beating my head on a wall here, dealing with that. So let's go look at the schematic. Okay, so this is the capacitor here, and I'm getting high resistance readings on these legs. This is a resistor that burned. How did it do it? Could have so I've been thinking of it as feeding power this way and too much and cooking it, but maybe it's going this way. Maybe it's going this way. The fault in the output transformer, that would be bad. We had a fault here. This was shorted. That wouldn't do anything, I don't think, because it's just on the other leg of the. I don't think it would. It just wouldn't do anything. Short within the tube. Well, it's very unusual. From the plate all the way to what? That's just not very possible. Although I could pull this tube out and see if. I really didn't find a really low resistance over here to explain anything at all. When I say short in here, what do I mean exactly? Short that turns out? Or a short to ground? If there was a short to ground in here, then the power would flow there. It wouldn't flow through here. The power's coming this way. Whoops. Oh, let's look at the weather. What's the weather for today? I clicked the wrong thing here. Let's just look at the weather. So I live right in here. Right in here. Stop jumping around. Right here. I live right here in the clear. And which way is the storm going? Just bear with me here because I like to know. It's going that way. Going away with a little bit of drizzly stuff here. Very good. Okay, back to what we were doing here. Okay. Always, I'm Canadian, so I got to check the weather like every 15 minutes. So I was saying a short to ground here would blow this. But how do you burn this guy up? You burn him up. It has to be. If it were going through here, it would burn this guy too. One of these is a higher wattage than the other, 400 and 401. Let me just double check that, make sure I'm not in Looney Town here. 400, 405. No, look at this, 404. What's going on there? Well, I was looking at this, 405. Oh, right. What? I'm totally lost. What am I doing? What am I doing? Valvo. 1, 402, 403, and 404. 20304. I'm looking for resistors 400 and 401. Oh, come on. I'm low on coffee so far this morning. Here we are. Yeah, both 1K. One is a 1 water and the other one is a third of a water. And Mr. Rosenthal. I worked with a guy who's, excuse me, last name was Rosenthal. Did he invent this? I don't think so. Okay, well, we're still on track here completely with... so if we're on track, what are you talking about? I don't even know. I'm babbling here this morning. Holy smokes. I keep opening my mouth and the words keep falling out. So we burned the high wattage one, but the low wattage one hasn't done anything. So the power's going this way. We don't think there's a short in here, and never really did. So the power would have to be going along this line. We have a resistor here, 47,000 ohms. So it's not coming through there. This is a bit of a mystery. 56,000 ohms. .8K, so that's 1,800 ohms here. But we have to find this resistor and see if it's burned up too. And this one is also 1.8, and it's right into the FM tuner. It's just not likely that you managed to pull current through this resistor. If you burn this out, then the high voltage is gone and the problem is gone. What if I supply my own voltage here? I put my own power supply on here with the radio not operating. Push, try to build some voltage on this. Let's see what happens. I'm in a blank here. I'm in a blank. Let's get more information. We need to do crazy tests and get more information. Okay, I really don't know what the result of this is going to be, if it's going to be anything significant at all. I can see the red wire going up. It's plugged into my high voltage power supply here. And it's on standby. I just have to turn this up and I'll raise the voltage slowly. And down below here, we have the positive lead, and I'm going to connect it first through the output transformer. Now, I redid the resistance measurements on this. I could not find anything at all that approached any kind of short circuit. So this should put voltage on the output transformer and kind of further through the radio too. And we'll just see if I can raise the voltage a bit and not encounter a short circuit, basically. How am I going to tell that? From monitoring the amount of current flowing from my power supply. How much should it be? Gee, I don't know. How much when I go, hey, that's too much, something's wrong? I don't even know that. So we'll just worry about it when we have to. Okay, so this is a voltage measurement, so I can see more precisely what the voltage is here. 600 volts DC is where I'm set. I'm not going to 600, that's for sure. Okay, so you're going to hear me snap. Whoop. Yeah, well, just one sec here. So I just wrapped my microphone badly. And let me just... there we go. Okay, microphone back on. Yeah, as I reached across, I slapped the microphone. So I'm going to turn on the power supply. Okay, and it's set to 0 right now. Usually there's a little bump, but we didn't see anything. Is this really connected? Yeah. Okay, I'm going to raise the voltage a little bit, and you can watch this meter, and I'm watching the current meter up here. You just let me know if something bad happens. Should be going up, up, up. Hey, it's not going up. This is not going up. But this is going up. What's happening? How come, what have I done? I've done something stupid. Using a bad clip lead. Yeah, a good guess, Jim. Bad clip lead. My gosh, they're dropping like flies in here. Another bad one. Oh my gosh. Let me set this one aside. I'm working my clip leads too hard here. Let's try another one now. Meanwhile, I've got 50 volts sitting on this. No evidence of any current flowing. So I think the test is actually complete already. No short circuit in this direction. That's what I would say. Okay, we'll put this on here. It's 42 volts. And no visible current on the current meter here. Nothing. Nothing. It's what you would expect. You know, the tubes are not heated, the heaters are not going, there's no tube current. Let's go up a little higher here. So, you know, I don't see anything happening here. Current-wise, there's no current at all. So that's going back through the output transformer. Now we're going to hook up to basically, I think, the rest of the radio. Can you put it that way? It's another wire that came off that terminal. I believe this one goes up around through the resistor and back down to the other side, the other terminal here. So this is a more... Okay, here we go. There we go. Going up. Again, no current being pulled, just charging current. Brief, very brief charging current. 7 volts. Wait a minute. I got 70 volts on here. What's happening going wrong now? How did this read so low? How's that possible? Because I'm not reading the right thing. That's how that's possible. I'm not reading the right thing anymore. There. Okay, let's try again. There we go. Okay, well, we're raising the voltage way up. And again, just a charging current. Wait a minute, there's a little more than that there. Okay, so at this voltage, you can see a little current on here. Now, how much is that? First, it's not very accurate. It's 150 volts. And you know, that would have to be, it's dropping off. It's charging some capacitor somewhere. It's dropping to 0, complete 0. So there's no short in that direction. Oh, we're getting back to just the resistor burning itself out all by itself. Well, there's another section of the capacitor I could do this test on. Let's drop the voltage here. Okay, we'll move the test to this terminal here. It's kind of the other side of the hot resistor. Okay. Here we go, raising the voltage. Once again, no current, slight charging going on. So up above it says 100 volts. So nice. This is probably accurate. My other meter's probably not accurate. No current flowing at all. Hey man, there's no shorts in this thing. What's going on? Let's look at the schematic here. I put this back on standby. So I've gathered some more information, and the information is if I sever this line and then pump in 150 volts here, no current flows anywhere. And then if I pump it in here, no current really flows anywhere. Well, that suggests the high voltage system in the radio is just fine. There's nothing wrong. So why did you burn up? Simply because you went up to 1350 ohms? Is that enough to make a difference? I have trouble believing that one, but maybe it is. Maybe that's enough. Maybe I'll do some calculations here and see what happens here if perchance the current doesn't change through the resistor, but the resistor itself goes up. Now, I don't think that's exactly what would happen, but that would be the worst case scenario. Higher resistance, same current as intended. And what is the current? Oh, they put it right there. What's that say? What does that say? Anybody read that? 19 milliamps, not 20. 19. Here's 50. 50 up here. 20 going this way. 30 going this way. 30. Some amount going that way. Well, 30. We can do some calculations with that. Wait a minute, there's even more information here. There's 245 volts on this side and 215 on that side. So that's a 30 volt drop. So we know the current and the voltage going through here. Okay. Okay, done my calculations. Here they are. What, did I win something just now? What happened? Okay, here they are. So this is with the everything running essentially normally. So 30 volts dropping across the resistor with 0.03 30 milliamps going through it. That gives you 0.9 watts. We calculated a different way using I squared R. You get the same value, 0.9 watts. Now the resistor that's in there is rated at 1 watt. Wow, that's close. That's close already. So this thing would have been running pretty warm. But what if the resistance has gone up to 1350? Well, then the wattage is 1.2 watts. Now, that's 1350 as I measured it. I'm going to measure it again, and if it gets hot, it might go up even more. So it might be 14, I don't know. I don't know what it would go up to. Maybe we can find that out somehow. So, is that enough to start the resistor cooking away? See, it could be that this wasn't really a dramatic thing that happened here. It could be this hot resistor just got a little hotter than normal and enough to cause some odor that you could smell. Maybe that's all that's happened here. Got to remeasure this and find out what's going on. So once again, I think I'm chasing smoke literally all around this radio. Maybe for no reason. So the resistor is up on top. Okay, let me just turn the high voltage supply right off. Take it off here. I'm going to break that antenna sooner or later. Okay, so the resistor we're talking about is over here. Let's just measure it in the circuit. Pretty sure I'm on my way to replacing that because it's not the correct value in any case. I don't want to use clip leads. $1,300 with it in the circuit. it is, 1360. So, you know, that's a 30% increase over what it should be. That's a fair bit. I'm going to nip off one side here. What's happened to my... Oh, this spring broke on my... Yeah. Okay, manual pair now. Let's nip off one side here. Because I have been around me for a long time, I know I can mess this up, so I'm going to put a marker clip lead on here. Pull out the resistor. We'll make another measurement of it. Whip it out of the circuit. Okay, Mr. Resistor, what are you saying now? What do you say? $13.57. Same reading basically. So $13.50. Well, I guess the best thing to do is to put a new one in here at 1,000 ohm. Maybe a 2-watter would be a better move. 1,000 ohm 2-watter. Have I got something like that? I'm gonna go look. So I've been hunting through my resistors looking for a 1,000 ohm high wattage resistor. I haven't found one yet, but just thinking about this, if the resistor went high and maybe when it's hot it gets even higher and it gets even hotter, that kind of thing, that doesn't explain how come the diode was faulty. Now, was the diode faulty or was my diode test faulty? I still have the diode. Let's put it right on this tester here. The test I did on it was a simple ohm reading forward and back, and what I saw said to me this was shorted. Let's see if I'm seeing things. What's this thing even do with a diode? 10 ohm resistor is what it thinks it is, and that's similar to the readings I took. What happens if you put a real diode in there? What does this guy do with a diode? That's a good question. Let me grab one if I can. I gotta hunt one down again. Okay, hunting. Okay, let's test the test here. I've got a small signal type diode. Let's see what it does. How smart are you? Huh. There you are. A forward voltage drop of just under 900 millivolts. And it's probably a reverse leakage of 1.6 microamps. The capacitance is too small for it to tell you what it is. So there you go. You can identify a diode. This thing it identifies as a resistor. Could it be this failed and this precipitated the overheating resistor? You know, that's a possibility. It's one way or the other. Or again, there's another factor I haven't discovered yet which is responsible for the death of both of these things. Looks to me like the name of the game now is put in the new diode. Not the new diode. Put in the new resistor, but I still haven't found a 1K resistor of sufficient wattage, and I'd like it to be more than 1 watt, 2 watts anyway, because of the duty it's doing. Oh, 1502 ohms, 1K5. Okay, I'm going to keep hunting away here until I find an appropriate high wattage resistor. Alrighty, I think I got one here. It says 1K 3 watts on it. That sounds about perfect for what I'm trying to do. $997.9 ohms. That's a little low. I think this one will do quite nicely. Perfect. Okay, so I had to clean up my bench here, and then we're going to install that resistor, and then we're going to run the radio carefully and see what happens. Okay, I think I'm ready for a power on test. It'll be the first time I've turned this radio on since it's been here. Volume control, tone control, tuning. Ooh, what's going on there? Tuning's not very happy. It's not geared down that far, is it? No, it's just slipping. Could be not enough tension. I don't know. Let me help it along here. One way's good. Hey, there we go. Oh, I just needed some exercise. I'll bet you it slips back here though. No. Don't know what was going on there. Very good. Okay, so we've got it set on. Volume is up just a bit. So I'm going to start this with quite a low voltage. I'm going to have only one dim bulb in the circuit. So it's not going to get much at all voltage wise. Now it has a diode that's doing the rectification for the high voltage. So as soon as I turn this on, high voltage is there. Then a short while later the tubes are going to warm up. With a low voltage, that'll take a long time. During that time I have a chance to make some tests over here. So I have the voltmeter hooked up to B+. We'll set it to 600 volts. This should come up, according to the schematic, to something like 240 volts. So that's what we're, 245 I think was the actual number. So that's what we're looking for here. With a low supply, this won't come up to 245. I'd be lucky when I start out if it gets even up to 100. But it should be there pretty instantaneously. So with the high voltage there right away, if there's some kind of thing going on, it should start going on right away. This resistor should start heating up. So to keep an eye on that, I'm going to have my thermal viewer at the ready. And we should be able to keep up with that. This is set to 45, puts a red color on here. It'll actually start a little bit below 45 degrees C. Now what bad thing can happen here? I don't understand the problem at all, and there's something more going on, and it puts the main transformer at risk. So we're going to want to be able to keep an eye on the temperature of the transformer, which went hot before, so I can do it again with my viewer. So we're watching the resistor, and we're watching the actually I'm going to turn the radio around this way because this is where the action is. Okay, I've reconnected the diode for anybody who's wondering if I remembered to do that. I did at the last minute. Okay, I think everything's ready to go. One bulb in. Here we go. Right away, we're looking. We're seeing nothing anywhere, of course. That's all we're getting is 12 volts. That's awfully low. Somehow I thought it would be much higher than that. The supply voltage is so low, it isn't even triggering this device to operate. That needs like 40 volts to come on or something like that. So even with this, can we find any heat? No, we're not going to find any heat like this. The pilot light's not even showing. Okay, let's crank it up. I can put the other bulb in, and that's going to raise everything up a lot. Whereas this bulb is very bright. Could that be because there's a problem sitting here? I'm lazily not looking for it. There's just no sign of heat in this thing anywhere. I mean, even the light bulb's not going. Did I not turn it on? Did I not? No, it has to be on. The bulb is going. So it has to be drawing current. So the suggestion here, even at this point, is there's something not quite right. This light should be on a little bit, wouldn't you think? I would think. Okay, so I'm going to turn down the voltage supply. Way down. I'm going to put in the second light bulb here. This guy's still not operating. Well, could be it's not operating because I have to cut it and then restart it. Still not enough to even operate this. So I don't know where we are. Still don't see the pilot light. Is the pilot light burned out? You know what? We're seeing heat in the transformer here already. Not much. But you know, should that be happening already? I don't think so. It's 30 degrees already. The windings on the power transformer at 30 degrees. Well, nothing in the resistor. This is just getting hotter. You know, 30 is not that hot, but that's what it is. 32. And I believe it's just slowly going up. So these do get warm to some degree, but they shouldn't be the hottest thing in the radio. We still don't see the pilot light. Got all of 30 volts here, next to nothing. Let's go a little higher. Okay, so this guy's trying to come on now. He's doing his best. 38 volts is what I can read on it. Transformer's getting very hot. Well, not getting very hot, but relatively speaking, it's 40 degrees now. The resistor is no show on the resistor. Okay, what would cause this thing to getting 40? Yeah, it's still going up. 43. Let's look for some voltages elsewhere, like it's the same measurement basically, 35. On the other side is AC voltage. Not really. Volts. I don't know what that means. You know, there's something missing here. I hate to say it. I just noticed. There's a fuse holder right here with no fuse in it. Right here. What's the deal with that? Okay, looking at the voltages across the... So this side shows a 0. This is what I found before. And the input side, if I can call it that, it's here. 0. Oh, because I'm on AC. Da 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 da. Try again. Okay, there's the 38. And on the output, 38. Either side of this resistor is the same voltage now. How do you get that? 38, 38.3, 38.2. no current flowing through there. Well, it could be the current that's supposed to flow through here is really from the vacuum tubes themselves. And they're not operating yet, I'm pretty sure. I mean, all they got for a plate voltage here is 38 volts, and goodness knows what little bit is heating them. You know, one of the conclusions that you can come to is the transformer itself has gone defective, which is not where we want to go. This thing would burn up. I don't think it would take other parts with it necessarily. So the fact that this resistor was hot before, it's not hot now. It's got to be the tube heating thing. How hot has this thing gotten now? You see the big red? Yeah, you can see it. The temperature now is 66. I mean, it's just a heater running here. I'm going to cut the power at this point. Well, yeah, so from here, it's a question of taking all the load off the transformer, or some of the load off the transformer, and seeing if it still heats up. And if we take all the load off it, and it still heats up, Jed's not a millionaire. First thing I was thinking before looking at this was, oh my god, how am I going to do this? But it actually looks pretty easy because there's only one line coming out of the transformer here, which I still don't understand what they're showing. But it comes up this way anyway, so it's the same place as the diode. If I just open this wire, I will have relieved the transformer of all of its duty, especially if I do it back here. But I don't think it makes any difference. We can lift it here. This is just lines on a page anyway, Jim. You can't make that kind of decision looking at it. And then this part will leave, which is the heater part. Running the heaters, and it's also running the light. The light did not come on. The light did not come on. This is easy to do, so I'm going to do this. But the light did not come on because there's a short out here. Would that be the case? Okay, let's nip that wire. Okay, so the wire I'm talking about basically is right here. And I would want to, it's actually this wire right here. I think if I disconnect this one, this goes into the transformer here, and the rest of them can stay. Isn't that soldered very well? Oh, it's not soldered at all. Son of a gun. Okay, but that's okay because we're going to separate it right now. Later I can solder it back up properly. I'm sure it was making contact though. This isn't exactly your best soldered spot either. I can practically pull the wire out. Okay, let's nip it here. Let's nip this. Oops. Might as well pull the spring out of my tool here. And I cannot do it. Okay. Hey, everything's going downhill today, so we're going to nip this. Now, so what this means is transformer no longer feeding high voltage at the radio at all. And we will start it up. It should be cooled right off by now. It's been a while. Just a gentle heat, 28 degrees, so it's still a little warm. Can feel it a little bit, not much. Okay, going back to having this guy operating. Why are we doing that? Shouldn't see anything there. Okay, once again, you can measure the output voltage of this wire too. That should be 250, 200 volts, something. I don't know. Something anyway. Something all right. Uh-oh. What are you calling about? What's up? Want to go outside? Is that what you're up to? Want to go out? You want to go in the garage? Which one? Okay, we're going to go down the hall here. If she makes a left, it's to the garage. If she makes a right, it's outside. Let's go. Come on. Which way? Down here? Go down here. I want to go down here? No. Okay, I want to go up here. Okay, I think we're ready now. Let's see. Thermal's ready. Voltmeter. I switched the voltmeter to AC and I've hooked it up to the end of the wire, so we can read the output of this transformer and see if it's there. So that should show up immediately. As soon as I hit the switch, we should see, I don't know, a couple hundred volts there, I believe. Okay, here we go. Dim bulbs, one bulb to start, please. Although really, why would I do that? Because I cut a wire, I think it can only be less. Let's leave it in. We'll leave it in. We'll start it up with a chunk of voltage here. Okay. Fire on. 24 volts. That's a bad sign. That's a bad sign already. It's already a bad sign. Now this guy's starting at 29 degrees. Looks like it's going up. Give it a few minutes. There's a lot of metal there to heat up. So 25 volts. That just... We're feeding the radio very low voltage here. 38 volts. I can hardly read it. 38 volts. It's drawing a lot of current. Both dim lights are on. So it's pulling a lot of current. How much? And this is barely working. On the wattage it says can't do it. Well, I can still read the voltage. 37 volts. Check the temperature. Temperature is now 40. There's no doubt it's going up. Okay, so we're going to shut it off because I don't want it to get too hot, because I'm going to run another heat run test. This time with no feed to the heaters. Now that could be a lot harder to achieve. One way to do that is pull out these tubes. I pull all the tubes out. The heaters won't be in the circuit anymore. That would be looking for a shorted tube. That'd be an unusual short in a tube. The other way is to find a wire that's running to the heaters and cut it from the transformer. That looks like a difficult thing to figure out. A lot of the wires are kind of hidden from view in here. Let's pull this out. Okay, Mr. Radio. I don't see any wires coming out. They probably shoot right down onto the board here. Maybe pulling the tubes out is the next step. I mean, that's easy. Doesn't hurt the radio at all. And then I'd be one step away from putting the tubes through a tube tester. Just looking at the wiring here. Yeah, I think I think what I got to do is pull the tubes out and run the heat run test again. Leaves the light bulb in the circuit. That's okay. If I pull this out and the light bulb starts working, then we're going to kind of know. I'm going to get these in the wrong order. Sure I am. ECC 85, EC 92. Okay, no tubes in. Current temperature is 34. 34 degrees, and I'm going to put this back on here. You might say, well, why would a short on the 6-volt winding cause a drop of voltage here? Well, I've restricted the supply voltage an awful lot, so maybe that's what's going on there. Okay, we're ready for another try. Yep. Dim bulbs in. And the same voltage here instantly. So it looks like pulling out the tubes didn't do any good here. I'm trying to do everything but find out the transformer's no good. That's the last thing. So the temperature here is 35.36, 37, 38. I think we know what's going on here. Still no light. Oh, the light is barely there. The light is barely there. Okay, 41. It's just going up, up, up. Did I properly, I'm sure I did isolate the high voltage here. Wow, so you have burned resistor, a defective diode, damaged transformer? Really? All those things together? A damaged transformer puts out less power. Less power means less heat, less strain. How would you burn a resistor out with less power? So the burned out resistor is completely disconnected right now, yet we're still having the same effect. I don't know. I'm silent here. It's time to stop and ponder. Let's stop and ponder. In fact, after a moment of thinking, I've decided to call it quits at this point today. Reason being, it's beautifully sunny right now, and I think rain's coming later today, so I better make use of the sunny weather. So we're at the point here where it looks like there's a defect in the power transformer. We don't know that for sure yet. Could be a short somewhere on the heater line, some capacitor or something. Okay, but that's it for today. So thanks a lot for watching, and we'll go at this again tomorrow. Maybe I'll have some fresh ideas. See ya.